In this section, we will discuss about the packet flow of multicast. In our previous video, we have seen or we configured multicast to handle the bum traffic into VXLAN. Now we will see how packet flows from host 1 to host 5. So you can see that host 1 on leaf 3, it is in VLAN 10, port number is 1 by 3. Host 5 is attached to leaf 5 on port number 1 by 3. Both these hosts are part of VLAN 10, and VLAN 10 on both leaf switches, it is a part of VNI 10.10.10, and they are a part of multicast group 239.10.10.10. Now let's assume that at very first host 1 does not know about host 5. That is why host 1 will try to find out the MAC address of host 5 if we ping from host 1 to host 5, right? So host 1 is going to send an ARP request. So the content of our request will be something like this. So the source IP will be 10.1.1.3. The destination IP will be 10.1.1.5, right? Then the source MAC will be the MAC address of host 1, 1111. Destination MAC will be all zeros because it is trying to find out the MAC address, right? So host 1 is going to send this particular ARP request to leaf 3. So leaf 3 received a bum traffic on port number 1 by 3, which is a part of VLAN 10 or VNI 10.10.10. So now it will put some extra information. So it will add the inner source MAC, which will be the MAC of host 1, and it will put the inner destination MAC, that will be OLF because it is a broadcast frame. Now it will add the VXLAN header. In the VXLAN header, it will put the VNI information. For VLAN 10, the VNI is 10.10.10. Then there will be the UDP header. In the UDP header, the source port will be random. Let's say anything 50123, and destination port will be 4789, which is fixed for VXLAN, right? Something like that. Then there will be outer IP header. In the outer IP header, we will be having outer IP header. There will be source IP. Source IP will be the VTAP address of leaf 3, which is 333, and destination IP will be the multicast address for this particular VNI, which is 239.10.10.10. This will be the outer IP header. In the outer MAC header, the outer MAC header or outer layer 2 header, there will be source MAC. So the source MAC will be the exit interface MAC of leaf 3, which is 3131. And into the destination MAC, it will be the multicast MAC address, okay, which will be derived from this particular multicast IP address. So this is the packet that leaf 3 is going to create. Now leaf 3 is going to send this particular packet to spine, okay. Once spine receives this particular packet, being a layer 3 device, normal layer 3 logic, it is going to modify the outer MAC header, and from the outer MAC header, it is going to change the source MAC. The destination MAC will be same as multicast, right? So in particular, if I talk about specifically what spine 1 is going to do, because we are running multicast, so in the spine 1 multicast outgoing interface list, already there will be Ethernet 1 by 2, which is leaf 4, because leaf 4 was also a part of uh, VLAN 10 or VNI 10 10 10 and multicast group 239 10 10 10. And also leaf 5 was also a part of this multicast group. So spine 1's outgoing interface list into multicast is already having these two interfaces. So spine 1 is going to send two packet, one for a leaf 4 and another for leaf 5. So the one it is going to send to leaf 4, in the source MAC it will put 0012, which is the MAC address of Ethernet 1 by 2, the interface connected to leaf 4. And the packet that it is going to send to leaf 5, it is going to put the source MAC as an 0013, which is the MAC address of interface 1 by 3. So I will just discuss about, because in our example we have taken only leaf 5, so we'll see the example related to leaf 5 only. So into the source MAC, spine 1 is going to put 0013, which is the MAC address of outgoing interface of spine 1 connected to leaf 5. So now this is the packet that is created by spine, and it will send it to the leaf 5. Now leaf 5 will receive it into the outer MAC header. You can see that it is a multi-destination frame, so which already leaf 5 is listening on, right, for this particular MAC, multicast MAC. So leaf 5 is going to receive this frame. Now it will check the outer IP header. Into the outer IP header, you can see that we have the multicast IP, and this is particular traffic is for VXLAN, right? And we also do have the VNI information, right? Now you can see that uh, so into the inner source MAC we have the MAC address of host 1. So host 5 is going to, let me remove this one. So now spine is going to save this particular information, that MAC address 111, which belongs to VNI 10 10 10. It is behind leaf 3, right? Or 3333. So this information leaf 5 is going to store. Then it will remove all the VXLAN related information. Now, as I mentioned in our configuration video also, that this inner source MAC and inner destination MAC is very, very important, because once leaf 5 received this particular packet, now based upon the inner destination MAC, leaf 5 is going to take the action. Now because into the inner destination MAC we have OLAP, or it is a broadcast, so leaf 5 is going to flood this particular or the rest of the information or the payload. It is going to flood into VNI 10 10 10, or in other words, it is going to flood this particular payload or ARP request into VLAN 10, all the interface that are part of VLAN 10. Now host 5 will receive this particular ARP request, right? So host 5 is going to store this information into its ARP table, that 11111. It is having the IP address 10.1.3, right? So this particular ARP entry, sorry, it is not 111, it is just 111. This is the MAC, right? And this is the IP address. So this particular entry will be stored by host 5, and also host 5 is now going to reply back, or it is going to send an reply packet to leave 5, right? So now leave 5 is also going to store information about this particular host or host 5, that MAC 555, it is in VLAN 10 and it is receiving it via Ethernet 1/3. And as we know that now, because when host 5 is replying back, it is just a unicast reply, right? Because in the source IP, it will keep its own IP 10.1.5. Destination IP will be 10.1.1.3. The source MAC will be the MAC address of host 5, which is 555, and into the destination MAC, it will be 1111. So this is the ARP reply, or it is the unicast ARP reply, right? So now leaf 5 also saved the information of host 5, and likewise when our host 1 sent the ARP request to leaf 3 will also store the information that MAC 111, it is learning it from Ethernet 1/3, right? So now leaf 5 will store this information, and also into the destination MAC it is having 1111. So now leaf 5 will check its MAC table related to VNI 10.10.10, and now it knows, because it already stored this particular information, that MAC 111 is behind leaf 3333. Now let's see how the packet will look like when leaf 5 will send it back. Okay, so we'll modify in this existing packet. So source IP, destination IP, let's remove it. So the source IP will be, so this is the ARP reply. So source IP in the ARP reply will be 10.115. Destination IP will be 10.11113. Then we'll be having source MAC. Source MAC will be MAC address of host 5. Destination MAC will be MAC address of host 1, which is 1111, right? So this will be the ARP reply. Now into the inner source MAC, there will be the MAC address of host 5. Okay, so let me clean it. So it will put into the inner source MAC the MAC address of host 5, which is 555. Into the destination MAC, inner destination MAC, it will be the MAC of host 1, right? VXLAN header, it will be same. UDP header, it will generate a random source port. Okay, I am not going to change it, so let's keep it like this only, just because we are doing some random example. So we'll be having the UDP header with the random source port. Destination port will be 4789, which is fixed for, you can say, VXLAN. Then into the outer IP header, the source IP will be, it will be the VTAP address of leaf 5. So 5.5.5, and into the destination IP, it will be having the destination tap address or the VTAP address of leaf 3. So we can clean the multicast IP because now the ARP reply, it is a unicast traffic, and leaf 5 already knows about the location of MAC address 111, so there is no need of multicast anymore. So into the destination IP, it will keep 333, right? Because it already having here, you can see that it is already having the information about 111, that it lies behind 333. And into the outer MAC header, now you can see that source MAC will be the exit interface MAC of leaf 5, which is 5151. Then the destination MAC, it will also be changed because it will no more be the multicast MAC. So we can remove it. And the destination MAC will be the, now again, simple layer 3 device logic. It will be the next hop or the interface MAC of spine, which is 0013. So this is the packet that leaf 5 is going to create, and it will send it to the spine switch. So now spine switch again, it will apply the simple layer 3 device logic. It will do some changes into the source MAC. It will put its own interface MAC, which is connected to leaf 3. So it will put source MAC as Ethernet 1 by 1 MAC, so 0011. And into the destination MAC, it will be the MAC address of next hop or this particular interface of leaf 3, which is 3131. Now leaf 3 will receive this particular information, right? And it is going to remove the VXLAN related information. Now you can see that in the inner source MAC we have 555. It is going to store this particular information, that 555, which is a part of VNI 101010. It is behind leaf 5 or 555. So leaf 3 is going to store this information. Okay. And you can see that into the inner destination MAC we have 111. So already you can see here that during the ARP request, leaf 3 saved this particular information that 111 is behind Ethernet 1/3. So it is going to remove all the VXLAN related information, and rest of the ARP reply it will send back to Ethernet 1/3 or to host 1. Now host 1 can store the information of MAC address against the IP address 10.1.1.5 into its ARP table. So this is how the ARP process is going to work into the VXLAN when we will do multicast into the underlay. And now as now the ARP table of host 1 and host 5 is already populated, and leaf 3 and leaf 5 already knows about the MAC addresses of the remote host. So now our traffic can go directly without using multicast, because now when the next packet comes in, host 1 will send a unicast ICMP packet, right, to host 5. So source IP will be 10.1.1.3, destination IP will be 10.1.5, source MAC 111, and destination MAC 555. When leaf 3 will receive this particular information, it will check the VNI table. And now because you can see here in the VNI table, it already has the information about 555, that it is behind leaf 5. So it can directly encapsulate the this particular packet into VXLAN. So again, in the inner source MAC, it will put the MAC address of host 1. Into the destination MAC, it will put the MAC address of host 5. There will be VXLAN header, UDP header. I think it's already clear. There will be source port, random source port, and destination port will be 4789. Into the outer IP header, the source IP will be VTEP 3 IP 333. Destination IP will be 555. Into the outer MAC header, it will be again simple layer 3 device logic. Exit interface MAC will be source MAC. Destination MAC will be next hop MAC. And it is going to send this particular information to spine. Spine again, it is going to modify the source MAC and destination MAC accordingly. And leaf 5 is going to receive this particular packet. It is going to remove the VXLAN related information. It will check the inner destination MAC, which is having the MAC address of that will be having the MAC address of host 5, and then it will send the packet back to host 5. So this is how the communication will go through host 1 to host 5 in case of multicast. So I hope now everything is making sense how packet flows between different hosts in case of multicast. In our next section, we will see something else. So I hope you enjoy this particular packet flow, and thanks for watching.